This is CHEM 100, spring semester 2023. I have two things I want to do today. First thing is I want to show you, excuse me, where to find everything in Brightspace. And if it works, I'm going to put Brightspace up here on the board and walk you through some things. We're not going to cover everything. The syllabus is your best friend at this point. There's lots of information in there, and it's been my experience that too many students don't even read the syllabus. And then later in the semester, they get in trouble and wonder why. Well, read the syllabus. If there's anything you don't understand, contact me. My contact information is there in the syllabus. So let's get to business here. Come on. There we go. Okay, so I want to go to My New River. So My New River. There we go. And the instructors will look, this should be about the same for the instructor and the student at this point. There we go. I'm not going to be able to scroll, I don't think. But you need to go down, you need to find banner. So let me scroll and see if this will work. No. That's because it's off the edge of the board. All right. Hold on a second. All right. We'll see if that'll help at all. So I can gain access to the scroll bar. But here's Brightspace. It's called Desire to Learn, D2L. So you just click on that. And then find your course. And the best way I found is to go up here to this waffle. Click on the waffle. And it'll give you selections. And this is your selection, CHEM 100 with CRN number 26515, right there. All right. Now, this is what's called the mini bar. And you can get to a lot of different things here. I think what I should do is change to the student view. So let's do student view. There we go. That's what it will look like for you. Now, I've got a note here on course modality. This course, I've been piloting for several semesters, this high flex modality. And it's not been in the catalog that way. It's either been web or face-to-face or some form of mix in between, but not all three together. And this course you can access either in person, come to class, Raleigh campus, room 1, R134, or you can attend by Zoom. And I'm connected Zoom right now and recording. And if I'm recorded, then I can post the recording in Brightspace. And if you prefer, you can attend the course web only. And you'll have these videos that you can look at and see another way for things to be explained. Now, there's some archived videos of previous semesters. And you don't have to wait for the one that I'm doing on the scheduled day. You can go back to an earlier semester and get the content from a previously recorded video. But you have those three modes of attendance. So how do you submit assignments and take exams? Well, you can, if you're face to face, you can take an exam on paper. If you're Zoomed or if you're web only, then and you choose, you can take the exam in Brightspace. And when you do that, and I'll show you where it is. When you do that, you have to use Respondus Monitor and Lockdown Browser. They are the that's the monitoring software, the proctoring software. And I'll show you how that works also. Or if you feel like it, you can do one test and a different way the other test, depending on your schedule. Okay, so let me scroll down a little bit here. Is it going to let me? No, it's not going to let me scroll down there. Yeah, let me do it manually. As my note on course modality, I'm not going to rehash that again. And there's a little welcome message. And we also have, we also have a tutoring service. One of our staff, Barry Pine, has a background in the sciences. And he will tutor my chemistry classes and my physical science classes, and maybe some others. But this is his contact information and the times when he will be available on Zoom. He only does Zoom in the evenings. So you can see the times here and the days. And there's his Zoom ID number. So let's see. Yeah, let me scroll. Okay. So past that, you want to get to course content. Course content is right here under content. So I just go up here and I click that. And if I can get to it here, there. Right. And the content, best way to start this, it's left off where I left off the last time. So if you go to table of contents, that'll set things back to where we're expecting them. There we go, table of contents. Now, there are some things here that are independent modules, and you can get to those down the left-hand side. You can do emails from me, send emails. You can't receive them, but you can send them to anybody in the class, including the instructor. And there's some things in here that are dictated by management. They say you've got to put them in here, so they're in there. Let's see. There we go. So if we come to start here, then I've got a little course tour that I recorded either last semester or maybe the semester before. When we first started using Brightspace, I recorded this tour. And it gives you a lot of the stuff I'm going to talk about today in that video. Then here's where you can find your syllabus. If you just click on that, then you get a syllabus document here. You get my schedule here. And if you were here face-to-face, then I would hand these out hard copy. And here's my Zoom link. If you just click on that during my office hours, then that will open up a Zoom session and I will be there on the other end of that Zoom session. So the syllabus looks like this. Let's see, here we go. It should open in a separate window. Here we go. And let's see. There's my contact information. Here's some other details about the course. Let's see. Oh, we need to do this. There we go. Scroll through it. This is the Zoom link for the class in session now. That's how you get to this class on the days that we offer it. 9 to 11 on Tuesdays and Thursdays. That's your Zoom link. And there are more instructions in the appendix. Also, let's see. There we go. Go too far. Textbooks. You don't need a hard copy textbook unless you just want one. So, and in a subsequent paragraph, I've given that information if you want a hard copy. But you do have to buy Cengage Unlimited. You have to buy Cengage Unlimited. And for this class, since you're only here for one semester, and if you're not going to take any other classes that use Cengage products, then the one semester version is probably the most economic. If you're going to take another course in a subsequent semester, say next semester should be, using Cengage products, then it's more economical to buy the 1-year license. And those prices are here, and they're both in the bookstore. You can buy either one in the bookstore. Don't need both of them, just one, either the 1 semester or the 1 year. And what you get with that is the electronic textbook, which is linked in Brightspace in the course, and you get access to the homework. And the homework is part of your grade. Now, when you register for the Cengage homework, you must do it from within Brightspace. They're linked. So when you register from within Brightspace, the linkage will send all of your work, the results of your homework using the Cengage application back to Brightspace, and I will see the results. However, if you register for the Cengage homework outside, independently of Brightspace, I won't see your work. So that'd be kind of a wasted effort. Okay, so there are the details for the Cengage product. Let's see. Let me see if I can do it this way. Now, there's the details for your textbook. If you want a hard copy, you don't have to have a hard copy. You also need a calculator. And I've given some details on the calculator here, the functions that you need. But to simplify it, if you go to a Walmart or Staples or somewhere, and you find a calculator that says scientific on the package, it will have everything you need. And I would suggest you buy the cheapest one possible, unless you just really want, all the bells and whistles. Walmart, you can get them for $10 or less if you don't already have a calculator. And you can't use the calculator on your phone to take exams, right? The respondus monitor will be videoing you, or if you're in class, I'll be watching. You cannot use your phone. Your smartphone, they have access to scientific calculators, but they also have access to the whole world, right? Which makes it easy to cheat. So you have to use a standalone handheld calculator to take exams. All right. So here's some other things that may help you, and just read the syllabus and you'll see everything there. Procedures for evaluation. That will come in the syllabus. You'll notice one of the most important things is, how do I weight the results of your exams and your homework? Those are the only two things that go into your course average. So the exams are equally weighted, and altogether they're worth 80% of your grade. The homework, weighted equally, is worth 20% of your grade. Let's see. And there it is. Okay. So I've also got repeated here, the connection for the Zoom link is also here. And this is your course schedule. It will tell you when we're going to meet. If you show up in person or if you Zoom in, that's when we'll meet. Those days we'll meet and the topics that will be covered on those days. And then it will also give you due dates for homework and exams. Right? The exams, face-to-face, you be here in person on that day for the exam. Or if you prefer only Zooming or only web, then those are the dates in which your exams and homework are due for that particular chapter or topics. And they're lined out here in detail. Here we go. So the first one is due on the 31st of January, and it covers chapters 1, 2, and 3. Now, it seems like a lot, and it is, but chapter 1 is almost nothing. Chapter 2 and 3 are where you get into the meat of the sciences. And these are the due dates for each one. These are the topics that were covered. Let's see, let me go up again. And I better scroll down a little bit. There we go. So today we're going to finish class business and we're going to do chapter 1. And as this is the way I do business is if you're in person, then stay through the whole class. And if we don't finish the material during that allotted time and there's no class coming in behind us, I'll just keep going until I've finished the topic and it's being recorded. So you can go back and look at the recording and pick up what was missed at the end of the class. And obviously, it's been my experience as a student and as an instructor that actually this doesn't happen just in classes, this happens anywhere. When you're listening to someone speak, you get about half of what they're saying, even if you take good notes. So if you can go back and look at the video, you see what you missed, and you can update your notes with the information that might be important or essential to passing the course. That's one of the reasons I like to record everything. So in these videos that I record, I can usually, unless they're extenuating circumstances, I can usually get them posted within 24 hours. And I go in and I process them for mistakes, for dead air, for video quality. And then I upload them to my YouTube channel. And in Brightspace, I post the link to that particular video. So when you click on that link in Brightspace to go to the video, you will end up in YouTube to watch it. Okay. So we're going to cover today, we're going to cover chapter 2. Next week, we'll cover 1. We'll cover chapter 2 next week. And then these are some extra days that I put in here just as reminders. The last day to add drop is Monday, the 23rd. Then Tuesday, the next Tuesday, this is on Thursday, this is on Tuesday, we'll cover chapter 3. That introduces all 3 chapters in 3 meetings. And then I reserve this meeting to review the material from chapters 1, 2, and 3. Now, what do I use to review? Well, there's a review document that I prepare. Let's see if I can, yeah, here we go. This is what it looks like, review document. And it looks just like a test. That's because some of my students like to go in and treat the document as if it were a test. Just take it like a test and then go back and grade it. Now, the key is in Brightspace. So This document is in Brightspace. The key is in Brightspace, and I'll show you where those are. And then you check where you're weak and you work on those problems. So you focus your energy on areas where you're weak. There's also another document that I produced. And let me show you what it looks like. This is a handwritten. It's in my handwriting, and I try to be legible. And what it does is it matches up numbers with the review document and how to work the problem. So what you do is you go in and you look at each problem and you work it yourself. If you get the wrong answer and you can't figure out why you got it wrong, go to the worked problems. And it will show you at least one way to work the problem. Very often there are two or more ways to work a chemistry problem, and I show you one of them. Okay, so those are some useful resources. And then the exam is on the 31st of January will be the exam. That's also when the homework is due. Now, if you're face-to-face with me, of course, you'll take the test right there. But if you're going to take it using Respondus Monitor and Lockdown Browser in Brightspace, you have till 1 minute before midnight on that day to be on time. Now, it doesn't lock you out after that time. It just tells me that you were late. So I can modify your grade if need be. But it doesn't shut you out. In fact, while you're taking the exam, it tells you have like 60 minutes or 90 minutes, however many, when you first start the exam. It tells you that you have that length. Actually, that's the length of the exam that's in the time slot. And if you go longer, it doesn't shut down. It stays open. It lets you complete the exam in one sitting. And then it just tells me that you ran over. That helps me gauge for the next semester whether I had it too short or too long, and I can modify those as needed. Okay. So that's the pattern. And here's the spring break, right? That's grayed out because we don't meet that. And this is the day, this Monday, of course, is not a meeting day, but this is when the mid-semester grades are due. I will post grades on that day. So you will have the results of 4 exams and 4 homeworks. Actually, more than 4, because there'll be 8 chapters. You'll have 8 chapters of homework and 4 exams that go into your mid-semester exam. So your mid-semester grade. So it gives you a pretty good idea of where you stand in the course in the middle. All right. So let's see. There are other things in here. I'm going to let you read them on your own. Let's see. If you take your exam on Brightspace and the camera's watching you, you need to at least be from the waist up fully dressed, and don't take the exam laying in bed, right? Treat the exam as if you were in class. Dress properly, sit at a table or a desk, and be in a quiet space. Don't have a bunch of animals and little kids running around, because the audio will pick that up and it will flag it as an anomaly. And then I'll have to go in and look at it. And actually, when you first start the exam, it'll have you run through a list of checks, and it will look for your image, right? Your image has to be centered in the screen, and it needs to be like that through the whole exam. Otherwise, it'll flag it again that you're missing from the exam. Lots of times, students will be okay at the beginning, and then they'll kind of slump, right? And then the video will maybe get half their face. And it'll get flagged. And I'll have to go in and look at it and see that it's okay. So it's just an aggravation. Don't wear a hat. Don't wear headphones, right? You can have scratch paper to write on. You can have your calculator. Can't have your textbook, obviously. There is a calculator built into the lockdown browser that you can use, right? Just be considerate of your instructor when you're taking the exam. Okay. So let's see, what else? These are some things that we have to put in the syllabus. And then I have a bunch of stuff in the appendix. I didn't want to put it in the body of the syllabus because it would stretch things out and be difficult to follow. So some of this stuff I put in appendices. This appendix is how to register for your homework. Okay. And we're going to go through that in a minute anyway. So I just want to show you that it's there. And then the second appendix, let's see. Oh, this is good information. Cengage has set up office hours at the beginning of the semester for a week or 10 days. Actually, they give the time. January 3rd through February 17th. They will have office hours at these times, Monday, Wednesday, Friday, or Tuesday, Thursday. And you can zoom in to the meeting. Let's see, let's go down here. Follow link. Here it is. Follow this link right here. And it will connect you with Cengage tech support. If you're having trouble, especially in the beginning, if you're having trouble setting up your Cengage homework, then if you go to them, you've already purchased it, go to them and they will help you get registered in your homework or solve any problems that you're having. Okay. This is how the Respondus Monitor and Lockdown Browser work in exams. So I'm going to let you read that on your own. I'll show you where all that stuff is in a minute anyway. Okay. All right, it goes through several checks. There's a practice exam. Before you take your first graded exam, I have built in a practice exam. And the purpose of the practice exam, and whatever questions in there, just answer it any way you want to, it doesn't matter. The purpose of the practice exam is to check out your equipment and see that you're running through the procedure properly. So if you have any snafus, they don't pop up during a graded exam. That would be tragic. All right. Well, there we go. And that's it for the syllabus. All right, so let's go. Let's go. Let's see. How do I get back up here? New content. There's supposed to be breadcrumbs up here. Oh, okay. It's on a different tab. There we go. No, that's not right. Yeah. There we go. Okay. Now there's your syllabus, and here's some, notice these are breadcrumbs. So you can go back selectively, walk your way back through. So we don't want to go to the syllabus now. we want to go back here to start here. And come on, there we go. And let's scroll down. Here's a separate office hour and contact information, just to make it easier to get to sometimes. If you're going to need a PDF reader, especially if you're going to take the course web-based, and this will lead you to a place where you can get a free version of Acrobat Reader, because all the documents in the course are PDF files. All right, so let's see. There's getting started with Cengage. Come on. There we go. This just tells you how to do certain things, registration, how to complete assignments. This CHEM100 might be useful. If your homework asks you to input scientific notation or chemical formulas, right? CHEM100 will give you instructions and practice doing that. So when you're actually doing the homework, you won't have to fumble around looking for the correct sequence of keystrokes or mouse clicks to get the job done. Okay. Let's see. Here's your e-textbook right here. There you go. And if you click on that and you're registered for course, if I click on it now, it won't let me in because I'm a student, right? And I'm not registered as a student. But if you click on that, it'll take you to the textbook. Okay. Let's see. Go down some more. Here's where you register. There's where you click on that one. And the first time you do, it will register, it will try to register you. It will ask you for information. And what you need to do is when you buy Cengage Unlimited, be sure to buy it using your New River email account, because the course is licensed through New River. And if you don't have a valid email account, it won't let you in. And if for some reason you're able to register without it, you have to go outside Brightspace and do that. And then the same problem, I can't see your work. So be sure and register with your New River email account. And from that point on, you don't have to come back to this page. Each one of the modules has a separate link to that chapter's homework. I'll show you that in just a second. All right. Here's where you connect for the Zoom class right here. If you click on that and click on this, it should. Yes, it's still thinking. There, it'll give you the meetings, and well, it passed the one that we're in now, but this Thursday meeting, see, is not available yet. It will let you go to that meeting, and it'll have another key in there. Let me see if I can get that key up. There it is. This is the one today. It'll have a start button. I've allowed students to start the meeting themselves. If I'm late, you just start the meeting and I'll show up eventually. Okay, so let's go back. That's where you go for every Zoom class meeting if you want to do it that way. Let's see, there's your practice test right there. That's the one you want to do. You need a web camera. If you have a laptop, it's got a built-in camera and microphone, so you don't have to worry about it. But if you're using a desktop, you may have to invest in a webcam and microphone. Most of them have built-in microphones anyway. Now, here are the modules. Right? So module 1 is the one we're in now, and each module corresponds to an exam number. So module 1 is exam 1, module 2 is exam 2, and so forth. So we want to go to module 1. Here we go. And this tells you which chapters are covered, right? And this is chapter 1 objectives. Just open that up and it'll tell you what they are. Let's see, periodic table, right? This gives you a copy of the periodic table, right? This is a previously recorded lecture on chapter 1, right? So you can view that one instead of looking at this one. That one's already recorded. Let's see, and there's chapter 2 and chapter 3 right here, right here, right here. Now, what you'll also get, let me go back up. What you'll also get here is the PowerPoint slides. Right here, if you click on that, you get the PowerPoint slides, and they come in 3 flavors. They come in the PPT file that you can load up in PowerPoint and look at the whole thing like that. They also come in the PDF file. So if you don't have a PowerPoint installed on the computer you're using, or you can do it with your smartphone too, you can see the PowerPoint files. It just won't have any animations. It won't have any embedded videos. So what I've done is I've created this one, an HTML file. If you call that one up on your computer, then it has all the videos, all the animations embedded in that file. And you can scroll through them and get the whole experience that you would in the classroom without using PowerPoint. Okay, and that's typical for all the slides, all the chapters. Slides are in those 3 flavors. All right. So once we get through with those lecture slides, then we come to review documents. Okay, so module 1 review documents here. All right. There. And here's that review document I showed you just a second ago. Here's the key that goes with it. And let's see. There are the worked problems. And here's a review session recorded, previous session. Here's your homework, okay? So you can come in here in chapter 1, click on that one right there. It'll take you, after you're registered, it'll take you directly to Cengage homework for chapter 1. Now this one is mastery technique. It's very short, very easy actually. The rest of them are based upon end of chapter problems that are contained in the textbook. The reason I used mastery for the first one is because they had no end of chapter problems available. So I had to use that one. Okay, and that's going to be the format. Let's see, review. So there's lots of archived videos in here. I put them in a separate module so that they wouldn't clutter up the field. Practice tests. These are Brightspace practice tests that you can use to drill yourself. Instead of using the hard copy document, you can go in here and practice those tests, and you can take them over and over again, and each time they're graded, they'll tell you where you missed problems, and you can work on those weak spots. But I won't see the grades. Right? This is just for your practice. And they'll give you practice taking Brightspace exams too. Now, the other option, let's see, here's the exam. Let me see, scroll down. There we go. It's not available yet, right? I put availability dates on it. So it's not going to be available until the date of the exam. But you'll also notice this other document here. Useful information, right there. Before you start the exam, go make a copy of this. Useful information. It will give you conversion factors, some formulas, other information that will be useful on the exam, and it's legitimate to have that with you while you're taking the exam. You'll notice that with the hard copy exam, the review has at the very end useful information. See that table down there? It's pretty small for the first one. It gets bigger as we move through the course. But that information is the same information that's in this link, this document. Okay. Let's see, what else do we need to do? I'm running out of time, actually. That should be okay. I got another hour left. We can get through chapter 1 in an hour easy. All right, so let's scroll back up. There are your other modules. The modules are laid out exactly the same as the one I showed you in sequence. PowerPoints, videos, review documents, and exam. And homework. Okay, notice here and in the syllabus schedule, you'll notice that when you come to the end, there's no final exam, right? Right there. There's no final exam, just the last exam in the final exam week, and you're done. I have to do it that way because there's not enough time to do all these chapters and then have time to review and prepare you for a final exam. So you just take the 9 exams and you're done. That's not such a bad thing either, because chemistry is a cumulative science. In other words, each section we go through builds on the previous one. So once you get to the end, you have to use everything you've learned before to work, to understand and work problems for the upcoming sections. So a final exam would kind of be redundant. All right, okay. So since there's nobody zoomed in, I won't take any questions. What we'll do now is we'll get out of the, excuse me, we'll get out of this. I think I've gone to the bottom. Yeah. These are just other things. Let me see if there's anything. We go to the top. You can always go back to the home page for the course by clicking this one. You can go to class list, and the class list will give you everybody that's in the class. Me, all the students, and actually I've asked information technology to put Barry Pine's connection in there also, so that he can access the information. And if you go to him for review, he can get into the course and you can talk about it together while you're in the Brightspace course. But that's where you can also send emails. We don't have any discussions in this class. There's just too much to do without having to do discussions and for me to grade them. Your grades are over here. Okay. So let me see, let me click on that. Everybody's interested in grades. Click on that, and let's see. So your grades are going to be listed over here when there are some. The grades will be here. This one shouldn't be there. Syllabus. I'm not doing a syllabus knowledge check this semester, so I need to get rid of that one. That might be confusing. Oh, extra credit. Hold on a second. There are 2 extra credit projects that are not due until the second exam. But there's some information that you will need. Let me go back to the top and go back to the content. I almost forgot about this one. In chemistry, we have a different alphabet. We call it the chemical symbols for all the elements. That's our alphabet. And you need to learn some of them, not all of them, some of them. So if we go down to, the reason I didn't see it because it's in module 2. So let's go down to module 2. Here we go. Okay. Module 2 is chapters 4 and 5. That's when we get into learning the symbols and naming compounds. Now, if you're like I am, you're probably not old, but if your mind's kind of stretched, and it takes you a little longer to memorize things than it used to, then if you get started memorizing now, it won't be as traumatic when we get to chapters 4 and 5. So the information you need to know which ones to memorize is in here. So let me go down. Let's see. Well, it's not scrolling for me. Yeah. All right. Let me just find it. There's the PowerPoints. Learn these element symbols. So click on that. And that brings up the document. That brings up a periodic table with the elements that I want you to memorize boxed in. So if you can see it, I don't know if it's, you'll notice it when you print your copy. These elements have red boxes around them, right? Not all of them have red boxes, just these. Those are the ones I want you to memorize. So, and notice on this periodic table, they don't have the names. So you got to look up the names that go with the symbols. And I found the best way to memorize this stuff is to make flashcards. Just get a deck of 3x5 flashcards or 5x7s, whichever. On one side, put the symbol, on the other side, write the name. And the process of making those cards will get the memorization started. And then you run through them, right? You know how to do flashcards and memorize stuff. You go through symbols one time and name them. The ones you get right, this pile. The ones you get wrong, that pile. And you keep going through them until you get them all right. And you go back and do it again. And then you flip it over and you go by names. You say, what's the symbol for this name? And you do the same thing. You just keep doing it until you know the symbols. You got to know the symbols or you can't do the rest of the semester. You're going to be completely lost without knowing the symbols. There, out of 118 elements, there are 60 some odd that you need to memorize. Notice also on this table that there are several of them with blue highlight. Pay attention to those, because when we start doing chemistry in earnest, those are the elements that occur in nature as diatomics. In other words, when you write the symbol, that's the element, but they actually occur as 2 of those atoms attached together, right? So there'll be diatomics, and when you write them in a chemical reaction, if they're elements in a chemical reaction, you write them with a subscript down to the right of a 2. Pay attention to those. Okay. So let me go back to the extra credits. And let's see, module 2. Module 2, there we go. Let's go down to the extra credits. Where are they? Did I skip them? Oh, here we go. Here we go. Getting to know the periodic table and 50 ways to name your compound. Let me click on this one first. Excuse me. This is set up as an assignment. So notice that the document you need is right here. But when you finish it and you want to submit it, you go down to here. You upload your submissions. You upload your completed document. Now, how do you do that? Well, there are the instructions right there. Right? And here's the periodic table that you need to fill out. Right? And the instructions tell you everything that needs to go in the table to get full credit. Now, what's it worth? Well, this particular assignment is worth 1/4 of an exam grade. So you have 2 extra credits in this module, and those are the only 2 extra credits that I have for the semester. But these 2 extra credits together are 1/2 of an exam grade. So if you do well on these 2, then you can build up some buffer in case you have hiccups later in the semester, then that'll help you through. Right? So what do you do? Well, you have to print them off and you have to fill this one out by hand and get yourself some colored pencils. They work best. And when you get finished with it, take both pages with your name on it and photograph them or scan them, right? And if you have the capability, convert them into a PDF file. If you don't, that's fine. You could submit more than 1 page. You can submit, take pictures of each one and submit 2 pages. I need for you to submit the first page because that's how I grade it. Then the second one, let's go back. The second one, module 2. Here we go, at the bottom. The second one is 50 ways to name your compound. Here are the instructions, and we'll go through those in class. So it'll probably be best if you hold on this one. Don't start this one until we get to the part where we start naming compounds. Then it'll make a whole lot more sense. Let's see if I can. No, it's not going to let me. How about this? Well, here are the assignment questions. In other words, it gives you a name and you write the chemical formula, or it gives you the chemical formula and you write the name. And that's on the second page here. There it is. So there's the places that you write them in. Okay. And then down here on the third page, I give you polyatomic ions. I'll have to explain what that means later. But you don't have to memorize all of them because they're right there in that table. I'll explain what that table does later. Okay. And then once you scan or photograph your work, you only need to submit, in this case, you only need to submit the first one. Put your name up there and submit this one. That's all I need for this project. Okay. So I think that's everything that Brightspace has to offer. Yeah. Let's see. Let's Let's go back up here and collapse it. There we go. Okay. So the next thing I want to do is call up the PowerPoints for, let's do this one. And here we go. PowerPoints. No, that's a PDF file. That's right, that's PowerPoint. There we go. A little slow. Come on. It's my thumb drive that's slow. It'll eventually pop up in a second. One thing I didn't mention about my office hours. I'm supposed to be in my office and Zoomed for those hours. You'll notice that the first one on Monday, my office hours are all Zoom. I won't be in my office for that one. But the other 3 sessions, I think, that I have set up for office hours, I'll be in my office and Zooming at the same time. But if you're going to come in person, or if you're going to Zoom, well, you'll know it. If you try to Zoom and I'm not there, that means I've been called away to do something else. I don't do that unless management insists, or I have an emergency in the family. And what I'll often do is, if I know that it's coming up and I've got to be away, I will open the Zoom and put a message up there to let you know where I am, so you don't sit around waiting for me. Oh, okay. Let me make a slideshow out of this. And let's see where it is. Slideshow. There we go. Now, is that? Yeah, it's on the screen. Okay. This is an introductory course to chemistry. So we're going to cover the whole field of chemistry in one semester, in 15 weeks, plus finals week. So necessarily, we've got to move through it pretty quickly and just kind of skip across the top of the waves. But there's some things that we do need to do in depth. Otherwise, the rest of it would be a waste. One thing you'll also notice is my slides are of a previous edition. All right, so when you go into Cengage, when you call up the ebook, it will have a different cover. It will have different borders and stuff like that. But the information is essentially the same. The only reason I haven't changed it is because I extensively modify these slides to suit me. And I don't want to have to go into a new set of slides and do that all over again. It's wasted effort. So you get everything that you need the way it is. And let's see. There we go. Everybody knows Grumpy Cat. He's passed away, poor thing. And he really wasn't grumpy. He had a condition called feline dwarfism. And he and his owners made a lot of money with it. But I want my students to enjoy this course. Now, fear of chemistry is a common problem among students, right? It's not unique for you or for anyone else. If you've never had chemistry before, you're going to have the fear of something new. Right? So just relax. Take things slowly, methodically. You have the deadline set. You know what to do when. I'm not going to pull any surprises on you. Just work steadily. And when you have trouble, come to me. That's what I'm here for. I'm here to help you fix problems. When you come to me with a problem, though, don't say, I don't understand. I can't fix those problems. If you've worked your way into a chapter or into a topic and it's giving you problems, then you should be able to tell me where the problems are. Then we can fix them. All right. So these 3 chapters we're going to cover in 3 sessions. The first one is just an introduction. Right? And it just has a few topics, right? So we should be able to get through that one in the time remaining. So the logical question is, what's the big deal? Why should I study chemistry? Well, I guess a valid explanation is because my program says I have to. And that's good enough to get you into the course. But chemistry is a whole lot more than that. In fact, chemistry is a massive field. It sucks in a lot of different sub-subjects. And chemistry, by definition, is simply the study of substances and how one substance changes into another substance. If there's no change into one substance and another substance, then you're stuck with physics. But there is overlap. There's lots of overlap between chemistry and physics. There's lots of overlap between chemistry and biology too. Chemistry, in fact, one textbook that I've seen that is used is called Chemistry, the Central Science. And they're not lying, right? You can jump on chemistry, your chemistry horse, and ride off in every direction. So why do we need to study chemistry? Well, to understand the natural world, right? And I might add, an understanding of chemistry, an ability to see the world through a chemist's eyes and to work problems and solve problems contributes to a person's development of clear thinking, right? That's a big problem these days. People have muddled thinking. They're emotional. They just, right? If it feels good, do it. Or I walk into the voting booth and I like the candidate's name, so I vote for them, right? In my opinion, that's just plain stupid. In a political sense, you need to know who your candidate is, what they stand for, right? Because your vote matters. And if you put so little worth is assigned to your vote that you would just vote for anybody, then you're better off not even going to the polls. But we need clear thinkers. We need more clear thinkers in this country. And chemistry will help you do that. It will force you, if you succeed in chemistry, it will force you to think clearly. But on the next level is we study new materials and we create new materials, right? For most of man's history, the stuff that we had was created from natural materials, stone, wood. Somebody invented mortar eventually, so that's a modification in the chemistry in its own, but it's derived from natural substances. But these days, a lot of the things that you use every day are constructed at the atomic level. The molecules are built up. Polymers are a huge chemical industry, right? Any drink you get, most of them are contained in plastic bottles, right? Those plastic bottles started out as petroleum or coal products or natural gas. And the molecules were built up to make that product. So these new materials are coming online every day to satisfy needs and to solve problems. Another is pharmaceuticals, right? The drugs you take to make your life better and to cure disease or to make you tolerate certain conditions, painful conditions, or make your eyesight better, right? I have glaucoma, and to preserve my eyes for an extended period of time, I put drops in them each night, and it reduces the pressure. Those chemicals were developed by the pharmaceutical industry. New energy sources, right? The world, contrary to environmental propaganda, the world runs on fossil fuels, right? In the foreseeable future, that's the only way that we can maintain our standard of living is with fossil fuels. But another source that's coming online, it's not purely chemical, but chemists are involved, is nuclear power. Right? Nuclear power satisfies a large portion of the world's energy needs now. And the only thing it produces is waste heat. Right? It doesn't produce any carbon emissions. It doesn't consume any fossil fuels. Right? It just uses the power of the atom to make electricity. New energy sources. I won't spend a lot of time at this point on renewable energy sources. Right? We cover that in a later chapter, and I'll pop up on my soapbox and tell you all about that one. Food supplies. Right? When I was coming up in the early 70s, we had what was called the Green Revolution. Two things were happening. Cheap fertilizers, primarily nitrogen, to help the plants grow taller and faster and produce more product, and genetic manipulation. In the beginning, the genetics were based upon crosses of naturally occurring variants of a crop and to produce the desired effect. And lately we have what's called GMO crops, genetically modified organisms. And some people, right, just don't want that in their diet. They think it's going to affect them adversely. But those two things, the genetic manipulations and fertilizer, caused an explosion in production of food. So instead of, when I was coming up, 3.5 billion people on Earth, now there's 6 approaching 7 billion people. How do we support that many people? We produce more food on the same amount of land. And I could go into more detail there, why it works and what the effects were, but we don't have time to do that right now. In fact, I should be fairly qualified to do that. My degree is in agronomy. My PhD is in agronomy, which is crops and soils. So yeah, if we want to talk off camera about that, I'll be happy to do it. Chemistry helps the environment. Now, in many cases, chemistry is responsible for polluting the environment, right? That's undeniable. Right? But that's not based upon the chemistry itself. It's not chemistry's fault that pollution occurs. It's the humans' fault. Humans not taking precautions and making shortcuts and trying to make a buck off disposing of their wastes inappropriately. Right? So it's not chemistry's fault that we have pollution. But chemistry, in the right hands, can solve many of those problems, can remediate pollution events. and can help the environment. You may be able to think of a lot of others. Okay. We're going to learn some principles of chemistry, things that have been developed over decades and centuries that help us to understand chemistry better. We're going to solve problems. In fact, solving problems is where you really do learn chemistry, learn any of the sciences. You get an introduction to the principles, right? Then you're presented with problems, and solving those problems drills those principles into your mind, gives you applications for the principles, and that's when your mind really latches on to them. And that's where you learn chemistry, is by solving problems. That's why I give you those review documents. You learn facts, you solve problems in those review documents, and there are a lot of them. I purposely give you a lot of problems to solve to give you practice. Then you will understand the principles and learn chemistry better. You'll have a better grasp. In fact, I tell my students, your two best friends in chemistry, or in any sciences actually, is curiosity. You always want to know more about something. And believe me, there's a lot to know, right? You can never exhaust that resource. And the second best friend is boredom. If you work these problems that I give you, and a lot of them are multiples of the same format, it's the type of problems. If you work those problems and you start working problems, I've seen this before, right? This is boring, right? This is nothing new, right? Curiosity and boredom, they're your two best friends in this course. Because if you're bored, that means you're working a lot of those problems and you're getting bored doing it. Okay. I mentioned what chemistry was already. We study substances or materials and the changes that they undergo. They have to become a different identity, have different properties, chemical properties, if a chemical change has occurred. All right, we mentioned that, central science. It's a running joke in the sciences that to a physicist, chemistry is just applied physics. But to a chemist, biology is just applied chemistry, right? And I guess I could add one. To a mathematician, all of it is applied math. Okay, so I mentioned problem solving. First thing you do is you understand the problem. And as far as test taking goes, what's the question? What's being asked? If you don't know what the question is, there's no way you can get the right answer. So understand the problem, state it clearly, even if you have to state it in your own words. What is the problem? It may require that you make observations. Right? The problem, of course, on a test, the observations will be given to you in the body of the question. Then you propose possible solutions. Now, we're getting in here to the scientific method. Test-taking technique just requires that you state what's the question, how do I answer it, and then work the problem. Now we're getting into the scientific approach for solving problems. And I'm talking about sometimes huge problems. And if you have a huge problem on a test or in the real world, what you try to do is, once you understand what the problem is, you break it down into manageable pieces. And then you may have several questions that have to be answered for each piece before you can get those answers and put them back together to answer the whole problem. Okay. So what we do in the sciences is, once we understand the problem, and that usually comes from an observation, we see something. Out of curiosity, we'll want to know why that happens. of what's actually happening when we observe it. Like, you know, why does that cloud form? That's physics. Why does, where does food go when I swallow it? Right? What happens in a chemical nature? Well, it goes past your salivary glands, enzymes are injected and starts breaking down the food. Then it goes into your stomach where acid starts working on the food again. And then it goes past your bile ducts where emulsifier is injected so that the fats can be broken apart and your body can access them. Those types of things. These are all chemical processes. So you make an observation and you ask a question. Then you propose a solution. You say, all right, I observed this happening. This is what I think is actually happening on the microscopic level, the atomic level. So you put that in the form of a hypothesis. I say, this is happening. Something that you can test. You can design an experiment and test the solution to that problem. You perform an experiment, right? And there are various ways to perform experiments. The scientific method is a format, a set of possible procedures for arriving at an answer. Right? They're highly malleable. They can, depending on your discipline, they can be changed to suit the discipline. These are general activities that we're going through here. You perform an experiment, right? And you get results, right? And then you say, do the results support what I thought was happening? Right? With a hypothesis, it comes with a prediction. In other words, if I set these conditions just right, and I let the experiment run, then at the end, I should expect to see X, Y, Z. And then you compare what you thought would happen to what actually happened. So, like I said, science is, a better word for it is a framework for gaining and organizing your knowledge. In fact, the word science comes from the Greek. In some contexts, science means knowledge. In other contexts, science means truth. So we could split the difference. Hopefully, we would arrive at something that is true by gaining knowledge about it. But we need a plan of action, something that other scientists understand, the steps that you go through. Because science is never settled. You hear that in the popular media all the time, especially those who want to control your life, who want to force you to think a certain way. They say science is settled. I mean, anybody who argues with what I just said should be banned, right? We don't want to hear from them anymore. Science is not like that. Those people are adulterating science by saying that it's settled. Science is never settled. Science is, the scientific effort is always testable by you again and again and again, or your hypothesis could be tested by someone else, right? You're responsible to your peers for the quality of your work and the conclusions that you draw from it, right? If you make erroneous conclusions and you're called out on it, that could be the end of your career, right? And especially if you lie about your results, right? That's happened, right? You get work published for which you can't back up your conclusions by the results. Or maybe you never did the experiment. You just pulled it out of thin air. Those people aren't in science anymore. Once they're found out, they're gone. So science is testable. It's never settled. That's how we arrive at the best answers for questions. All right, so how about this method? That's kind of small, right? What I do when I process the video is I arrange things so maybe I can expand it a little bit and make it show up better. But we have a sequence of events in general where we have this observation and then we propose an explanation for it, our hypothesis, and then we do an experiment, right? To test the hypothesis to see if our assumptions were correct, right? Did we make a guess, a good guess? And then what that may stimulate is more observations and goes in a cycle, right? The results of an experiment usually produce several outcomes, possible directions that you can go with it. And what you can eventually do is produce this description. Let's see. Yeah. The first thing that usually comes from the results of experiments, several experiments typically, is a law. So what is a law? A law simply says what happens under these conditions. It makes no attempt to explain why. So the law of gravity. If I take this ball where I am, imagine I have a ball in my hand, and I let go, it will drop to the floor. Maybe it'll bounce, maybe it'll just sit there. But that effect is a law. I don't know why it happens. In fact, Isaac Newton struggled with why gravity happens, and he couldn't come up with an explanation either. In fact, he just called it action at a distance. But the laws, and those are the first things we're going to study in any of these topics, is what are the laws, give you a way to predict outcomes if the conditions are right, if the conditions fall within the purview of that law. But very often, one or more laws are developed, and over time, someone says, wait a minute, I have an idea why these laws are working the way they do. And they propose a theory that says this law or that law or these laws, they work that way because this is actually happening underneath, usually at the atomic level. And when they propose this theory, it's more often than not accompanied with a model. Now, the model is, I think of model airplanes or model ships. They're not the real thing, but they represent the real thing. And that's the model of a theory. It's a representation of what's actually happening that dictates how the laws behave. And the nice thing about a model is you can change it, right? You can change the shape of the airplane's wings, or you can change the shape of the hull of your ship, and then test it and see how does it behave. Right? So the theories are much broader in application. And that's the good thing about theory, is you can make a prediction before you even propose a hypothesis to test in an experiment. And if you don't get the results you want, you can go back and modify your theory, right? And iteratively get closer to reality. Okay? All right, law summarizes what happens. There's usually a hypothesis associated with it that can be tested. A theory attempts to explain why. All right. So, okay, I was just thinking for a second to see if I needed to cover a topic now before we get there, but I think I'll wait. Which of the steps in the scientific method is missing from this following situation? Okay, so let's see. Your instructor is holding a balloon, quickly inhales some of the gas inside the balloon, then he speaks and his voice changes to a high-pitched sound, right? Everybody's done that with party balloons. He then asks you to determine what gas was inside the balloon that he inhaled. Based on your observations, you conclude that the gas must be helium. Okay. Well, let's see. What steps are missing? Let's see. We made an observation, correct? We observed that inhaling the gas gave your instructor a high-pitched voice. And then the student or the person concluded that it was helium. What's missing? There's no testable hypothesis. Right? There was no hypothesis that it was helium, and you would have to devise an experiment to test it. That's missing. Right? We did state the problem and make observations, but we didn't perform an experiment. Right? I guess you could assume that the hypothesis is that you think it's helium, but it was never tested to prove that it was helium. All right. All right, I mentioned this before, learn the vocabulary. The vocabulary for chemistry begins with the alphabet, and the alphabet is chemical symbols. So go ahead and start learning those. You won't need them until we get to chapter 4. Right? So you can gradually work your way into it. Some important information just has to be memorized. Now, memorization is a highly underrated skill set. People that can memorize have those facts available to them at any time. You don't have to go look up facts in order to put them together and make an argument or draw a conclusion. So memory's not bad. You just don't want to memorize some things. You don't want to memorize a certain way to do a certain problem with certain facts, because then you're stuck, right? If you're presented with different facts and some condition changes, then you don't know how to approach it. So that we don't memorize. But you do memorize certain things. You want to learn processes, things that are malleable, that can change with the needs of the problem. Find out where your mistakes are. That's why I give you that review document. Run those problems. Find out where you're weak, and then work on your weaknesses and bring those up to the same level as the stuff that you know. Don't just sit on the stuff that you know and feel good about yourself, because the stuff that you don't know and you're not good at will come back to bite you later. And always ask questions. Be curious. Okay, that's the end of chapter 1. And let's see, in chapter 2, we're going to introduce measurements and calculations in the sciences. What is this information that we're gathering, right? We need to have an agreed upon standard to make measurements, and then the calculations also have standards with them too. We're going to learn those in chapter 2. So I would advise you, it was okay if you hadn't got your textbook and you haven't read chapter 1 yet, that's fine. But hopefully by the next time I see you, you will have registered your homework and gained access to the electronic textbook, and you can read chapters 2 and 3 ahead of time. It's better to read them first and then hear me explain some things about them, then things start to fall into place. All right. Well, we're finished early. That's unusual for me. I tend to digress. But welcome to Chemistry 100, and hope we have a stimulating, enjoyable semester.